it's getting recorded, right?
Yes.
Yeah, okay. So our first problem is like we have to add two binary strings and return their sum, and the sum should also be a binary string, and none of the strings will be non-empty, and it will contain only characters 0 and 1. So yeah, and you are not supposed to use, I think, any inbuilt library like for converting. So each it will consist of 0 and 1, and each string is 0 and does not contain any leading zeros. Yeah. So
Yeah, I don't think there is any library, right, in something like that.
yeah, like I thought converting it directly to int. I mean,
Oh, okay. Something like 8y and all that. Okay, I got it.
exactly.
Yeah.
I think although in Python we have that bin function, right, which can directly convert into integer and then can sum
Yeah,
again return back
dot
the binary value.
dot bin is there.
Uh-huh. Yeah. So this again looks more of a string parsing problem,
Yeah,
right?
string parsing.
Yeah.
Yeah.
But only one thing we need to take care of is when we are adding two of them, it's binaries. So we need to do a binary sum and just take care of the carry. And if we are adding those two strings, if the other string, the resultant string is of a bigger size, then we need to take care of that also. Yeah, maybe, may not. Yeah, that's fine. Yeah, the way we actually designed that. Yeah.
Yeah. I mean, the same like string parsing what you're mentioning.
Yeah. And the MSB is the first character or is the last one?
MSB is your last one, I think. I mean, this one from right side.
From right side.
That is the LSB.
Am I
LSB,
correct?
I think LSB, yeah.
think
The other
This-
way.
I think MSB is the leftmost one.
Okay, okay. No, sorry.
Yeah.
Yeah, because 100 is 4, right? So 1 is 3. 3 plus 1 is 4. So 4 will be 100. So MSB is actually leftmost one.
Yeah, that makes sense.
The most significant bit, you know.
Correct, yeah.
But when I think LSB left node, to my right, left, okay. I was taking care with hands, left and right. So that's it.
Yeah, no. So you will have to start from the end of the string, correct? If it's a C++.
Yeah. Yeah.
So you start from the end of the string for both of them, you start adding them, and then you move to the first one. That is the leftmost character, correct? Yeah. Yeah. The code looks to be straightforward. It can be done iteratively as well as it can be done recursive.
Exactly.
Right? So that might be two approaches. Yeah. So anyone wants to share their code? Any more approaches to discuss?
So mine was like just I calculated the length of two binary strings, and as long as you finish the both the array, like both the strings, the length becomes 0. So total is where everything will be all the carry plus both the numbers will be taken. So I took the first number a of I, converted to int and added to this, and since I have traversed this string, so I reduced it by -1, and again I took second one and reduced it by -1. After that I'm doing mod to whatever result. Let's say I'm getting 1 plus 1 2, so your result will be what? 2 mod 2. 2 mod 2, that means 0, right?
Yeah.
So here I'll append 0 and carry whatever carry I get. Let's say my total is 2 by 2. That means 1 will be the carry. 1, 1, 0 and 1 will be the carry. So carry will be gone to 1. And again this carry, this will keep on repeating till you hit the. Only crucial part is like I'm taking both 0. Like if the sum is 1 by 2, if you do, then in that case your carry is 0, right? It's a division operation, integer division.
But at the end, if you have one carry left when you are out from that while loop, so should you not take care of that also?
That will be, yeah, if there is a carry, while carry, I have written carry also. If there is left
Oh,
carry,
yeah, I missed
uh,
that part. Okay.
this is like inside sanity check I'm doing. Like if I is left, if J is left, like,
Yeah, that's correct. Yeah. Yeah, I also did the same approach. So yeah, that's good actually. You did it complete. You also took care of the carry in the while loop. Yeah,
yeah, yeah.
that's good. Yeah.
You want to share the code like in C++?
No, that's fine. Actually, it is exactly the same what you've written. So if you have some other solution or some other approach, yeah, we can discuss that.
Sure.
Just convert to binary to integer value, like write your own function which will convert binary to integer, and then integer to binary.
But will that work? Because if you convert to integer to binary,
Yeah, I think I was also trying to say, I was also
yeah,
thinking that, but it will be too much of a code because you'll
Yeah,
convert
yeah.
into 3 plus 1, right? 3 plus 1, 4.
Right, right.
Yeah,
Oh, you mean to say taking the binary values and converting to integer? Oh,
integer,
okay.
yeah.
Yeah, that's
Right.
interesting. Yeah, that is.
But
Did
again,
you
you have to convert
implemented
back to
that?
string.
Yeah,
So
that's
in
true.
that case, thus res into 2 plus next bit you have to do. I mean, every bit is a multiple of 2, right?
Mm-hmm.
Right.
Yeah. I like,
So
yeah,
it will,
that,
so it's basically like iterate over the value a and b, like create int a and int b, and then do like a plus b, and then convert that sum back to binary value, and then return the binary string.
yeah.
Hmm.
I think
Will
essentially this
not use
question wants us to keep it to strings only. I mean,
Right.
two integers becomes a bit easier and that takes away the question.
Yeah, that's true. But if we have a different approach also, yeah, that should not be a problem though. In case if we are not able to recollect this one, so you can use that too, right?
Right.
At the same time, yeah, that's a good one. So, do you want to share Ronnie or Harshit?
I actually like
Yeah.
use the inbuilt library functions like binary and integer to convert to integer and binary respectively. I didn't code the function myself.
Okay.
I mean, I had this approach in mind of string parsing, like Shashank and you did.
Uh-huh.
So I was like, okay, I don't want to spend too much time on it.
What is
Let's
that
move
function
on.
which converts?
Sorry.
What is the function which converts? Is it st
So
stoi?
yeah, actually, STOI supports for like you can convert it into different bases like 2, 3, 4, octa, whatever binary. You can do that using STOI.
Oh, so you just have to pass a parameter for that, right?
Yeah.
Oh.
There is something like ATOI. What is that?
It's same as STOI. It's just the C version for STOI. So STOI is C++ and ATOI is C.
Okay. Somebody is
Okay.
sharing?
I don't think so. So,
Okay. Then we can proceed to next. So next is like maximum width ramp. Array of integers is given, and a ramp is a tuple of values where your every I mean I would be less than j, and the value at index I will also be less than equal to value at index j. And width of the difference between these two indexes will give you the width of a ramp, and you are supposed to find the max width of a ramp index. So in the case here you can see 1 and 5. You'll have. So I think here is a mistake, right? 0 and it should have been 8, right?
No.
No, I think lower value to the next. As long as your value is higher, is keep continuing. So he's noted down the first index like 1,
Okay.
and then he's checking next number whether it is less than 0 or not. So there is no number less than 0, so he's continuing.
so the difference is between the indexes, not the values.
No, not the value.
The
Okay,
f-
okay.
the 4 comes between with 5 and 1, right?
Yeah, this one,
Yeah.
yeah.
So even
So
at
once,
your index, like if you have a 0 at one index, and
Yeah.
if you had also 0 at one index, and if you had 1 at the fifth index, still that would have been fine.
Yeah, yeah. So as long as he doesn't find which is less than 0. Anyway, here number is not less than 0, right?
Yeah.
The least number is 0.
Yeah.
So the biggest longest sequence will be this one. If this number 9 comes at like 11th index, then it will be 1 to 11. It will be.
Yeah.
In fact, if the number is same as a of I, like in this case, if 5 is 0, then also it would work because
Yeah.
it says
Yeah.
ai less than equal to it.
Yeah.
Yeah.
That's a good observation. Yeah. I also missed that point. Yeah.
Yeah.
So it should be slightly greater than or equal to this number. Then it is going to be fine. Yeah.
Yeah.
Right.
Yeah.
And the length is the constants are the length is 50,000, right? Shashank actually went in the mute mode, it seems.
yeah. Length is like 50K.
Okay. Yeah,
Yeah,
50K,
yeah,
right? I thought you
yeah,
had, we lost you again, therefore I was
yeah,
just wondering. Yeah, no problem. But this problem is not a very, you know,
it,
normal problem, right? It looks
yeah,
very easy to solve.
exactly.
We have not come across any of such type of problem, right?
It's
It's not
like
a standard problem.
trying to check the farthest element. I mean, for every number, for every index number, you are trying to check the farthest element. Like we have no, what would be the next smallest element for this index? Such numbers, such I think it belongs to that category.
Or maybe like a monotonic stack use.
Exactly. Yeah. That gives the intuition of
Yeah.
monotonic. Like for every, I mean, in array, you have to find what will be the next largest, subsequent largest number for this number. So such problems generally we use stack and all, right?
But we are looking for the index, correct? We are not looking for the value.
Value.
So that
Yeah.
becomes more trickier, yeah.
So we're looking for both, right? I mean, J should be greater than I as well in the condition.
Value should, yeah.
Like, I mean, both should be, index should be greater as well as the value, right?
Yeah, the
Yeah.
answer is
Yeah.
defined by the index itself.
So therefore, I said like a monotonic stack, usually we use it for values. But if it is an index, it might be possible to use, but it will be slightly, tricky to do.
Yeah.
Yeah, we have to keep the indices in that stack in some sequence.
Yeah, that is also will work.
I tried with, I haven't implemented completely, but I the decreasing values and only the possible values I'm keeping it in the stack. It's not a stack, at least it's a decreasing one. Just store only the possible values of in the decreasing order.
Okay, so you used two separate data structures. One is for the decreasing values.
So I think what he's saying is that he's maintaining a stack where
Uh-huh.
he's keeping the indices in decreasing order because
Okay.
let's say because suppose we have a index which is greater, then that is of no use because we already have something lesser on the left side. So I think this is what he's trying to say. Maybe.
Okay.
And maybe iterating from the other end and checking if my value is greater than the value at stack top of the stack, and then doing that.
Okay. Okay, let's see if first Uday has
So
something to share. Is it Uday want to share something?
Maybe we can go with Shashank.
Okay.
I haven't tested it. That's why.
Okay, no problem.
I think someone else also wanted to chip in.
Oh, sorry. Yeah, good. Who was that?
Somebody wants?
so let me,
Sure.
yeah. Okay. So uh, uh, let me write the numbers first. 608215.
8215.
8. Yeah. Okay. So what we have to do is we have to find the maximum width. So let me write the indices numbers also. 0, 1, 2, 3, and 4. Here comes the 5. So what
I
my
think your video is lagging, or it's good.
let's list out what all possibilities we can have. Is it visible?
I think it's fine
Hello.
now.
Oh, yeah. So we have these list of numbers. Let's list out what all possibilities can occur based upon this condition. So we should have a condition such that I should be less than j, as well as a of I should be less than or equal to a of j. So what all possibilities can come, we'll just list out them. So as 6 is I should be less than j, as well as a of I should be less than or equal to a of j, right? So when we want to first we'll list out all the possibilities. So we can have 0, I mean less than 8. So in this case we'll have indices 1, 2, and next 0 is less than 2. Indices are 1, 3, and 0 less than 1. In this case indices are 1, 4, and 0 less than 5. Indices are 1, 5. Again we may have as 8. If we take 8 is not less than 2, 8 is not less than 1, 8 is not less than 5, so we'll leave out that part. Next we will take 2, as 2 is less than as 2 is not less than 1, 2 is not but we have 2 less than 5, so we will take this part also. So 3, 5, and next number is 1 is less than 5, so we can have 4, 5 also, right? So these are all my possibilities, and of that this is having the maximum width, right? So what we can have is we have to so I'll just declare a stack, and then what I will do is so in the stack I will insert both the number as well as the index. So uh, so let me have a stack. So if the top of the element let's the first number which is coming up is 6. So I'll just write one thing and explain. So if the top of the stack is So if the top of the stack is less than the number which is coming up, then I will so if the top of the stack is less than the number which is coming up, then I will try to insert it. If not, I'll try to find the difference between the all the numbers which are present in the stack and the number which is coming up. I mean, I'll do the difference between them. So let's suppose, and if the stack is empty, I'll just insert that number. So as the stack is empty, 6 is coming up, I'll directly insert into the stack, and the next number which is coming up is 6. So I will check if my top of the stack, which is 6, is less than or equal to the current number. Sorry, if greater than or equal to the current number, then I will just insert it into the stack. Or else, I mean, this will be the iterative process. So the next number which is coming up is 8. So I will check whether the top of the stack is greater than or equal to 8. So here, as 0 is not greater than 8, what we will do is we will so here we got the minimum element, and the number which we are iterating is 8. So what we will do is we'll take each and every element present in the stack. Here I'll be storing indexes also as well as. So this will be 0 and this will have index of 1. So as long as the number with 8 which is coming up is fails this condition, what I'll do is I'll be checking with each and every element whether the so this index will as this condition fails, what I'll be doing is index this 1 minus 2 minus 1 will be 1. So I'll be initially declaring with a variable called answer. So initially I'll be keeping just with as the width will be 0. So here what I got is if I do indices between 0 and 8, I'm getting the difference of 1. So I'll compare the max of the previous answer as well as the current whatever I got, and I'll pick the one which is maximum. So 0, 1 will be 1. So 1 will be my maximum now, and again I'll iterate to all the elements which are present in the stack. So the next number is 6, right? And 0 is this has the index of 0. So as index of 8 is 2. 2 minus 0 equal to 2. So in this case, max result is 1. I'll compare 1 comma 2, and here in this case, as 2 is greater, my answer will be updated to 2. So the next number which is coming up is 2. So it will compare this top of the stack 0 is whether it's greater than or less than. So as long as the top of the stack is
So are you like reinserting those elements or completely popping them off?
It's a decreasing stack,
no,
right?
as long as the element is less, yes, it's a decreasing stack.
That I understood,
Yeah.
but when you
As
move
the so I'll be finding the minimum till, sorry.
so when you move to 3, the third index, so you don't have
Okay.
0, right, in the stack.
No, I'll not remove this 0.
But then how do you reach on to 6, the 0th index?
0th index. So
Yeah.
I can have a while loop, right? Which initially I can have the length of the stack as so here length of the stack is 2. So I can just now this will have 0, right? If while I'm iterating, I can keep a while loop with stack which has stack the element I can get a stack of this length. Then I'll be getting this element stack of length of -1 as indexes start from 0. and after that I'll do this L minus 1. So I'll be having 1.
Not possible, no, because in the stack you
I
only
think
access elements through one side.
I think she is using an array. Can we just look at the code also?
It's a
Yeah.
totally
Yeah.
List.
So I said I'm inserting a tuple, right? Index as well as the number also. So initially I'm declaring a stack as an array. So then what I'm doing is initializing a variable res. Then what I'm doing is I corresponds to the index and the number. So initially 6 will be my number, and as the stack is empty, I can just append it to the stack, as I can append the number into the stack with index as well as the number. So in 6 will get appended into the stack, and the next number which is coming up is 0. So as top of the stack, length of the stack is not equal to 0, but we will be checking whether top of the stack is greater than the number. As top of the stack is greater than the number, I'll just be inserting it into the stack with the index as well as the number. And the next number which is coming up is 8. So now the top of the stack is 0. Then what we will do is, so it will fail this condition as 0 is not greater than 8. So it will fail, and it will enter, and length of the stack is also not equal to 0. It will enter into the else part. Then what happens is, so I'll be having in the stack with the elements 6,
I think
like
it is
this,
stack, but
I
behaving as an array, right?
right.
That's why we are
yeah,
not popping out.
yes,
Yeah.
yes. Here we can use, that also. We are not popping out any elements.
We don't have this.
We are just finding the minimum and then proceed. So here it will be having like this 0 index, and at the 1 index we are having 0. So this will be my stack. And the next number which is coming up is 8. So as 8 is, length of the stack is now is 2, which is not equal to 0, as well as top of the element, 0 is not greater than 8. So it will enter into the else part. So in the else part, what is happening is until the number, uh, until index,
Yeah, you
in
keep
until the
comparing,
length
right?
of the stack is,
Yeah, you
yes,
can
I'll
keep
just
comparing
compare the
that. Yeah,
all the stack elements
whatever you want.
and
Yeah,
try to find the width between
yeah,
them. So if the width is maximum, I'll be updating here, and I'll be checking initially one this will be checked, and next this will be checked. So
yeah.
I'm doing x minus 1. So all the
Right.
elements will be checked.
Yeah. So this is good. Yeah.
Yeah,
Actually,
it's
she's trying
monotonic
to,
stack.
yeah, sort of a stack, but using a different implementation. So trying to do the similar way what Uday was saying, right?
Yeah,
Yeah.
it was the
Yes,
same, and
Yeah.
I
yes.
was
Okay.
also trying to do the same.
Right.
This
Yeah.
is the brute force solution, I believe.
But yeah, this was a very optimized one. I was thinking, why can't we come with a brute force first? Yeah, because this would be the best way to
Brute
do it.
force
Yeah.
also I have
For rows.
So brute force would be,
brute
you
force also I
have
have
those pairs, right?
done,
Exactly. The
right?
same
So what
pairs you
we
can
can do is,
actually sort them based on the values, and then you can use comparison. So that will be the brute
You
force. That's what I think, right?
are
Uh,
you
what is the runtime complexity of this one? Was it n square?
Yes, looks like.
Yeah, it
no?
should be.
Why?
I think
so
I
we
don't
are
think so.
iterating only once this numbers, but until the stack is as long as the elements are present here, we will be comparing with these elements. So
Take an example of an
will be order of
ascending
n.
order sorted array. You'll understand. It is n square only.
worst case.
Yeah.
No, no, no. I mean,
I
the worst
I
case would
don't think
happen
so.
with
Worst
increasing
case.
or decreasing.
Yeah, I don't think so. It'll go in square.
But
No,
she's
no, it will
stopping
be
as
somewhere
far as
in between. Increasing and decreasing, you will get an n square kind of thing.
I mean, it looks like it might get n square, but I don't think that it is possible to get n square because
No, no, no.
because
It
the
will
stack
be
is
possible
decreasing.
because No. If you keep increasing, decreasing, you will almost get an n square kind of thing.
Yeah, that is what everyone is saying, right?
Yes.
Yeah.
Yeah.
Yeah, but
But still,
That would be the same
So
as
for
the
each
brute
element
force, right?
until the
No. This is not actually brute force. You are actually comparing only with the valid candidates.
yeah.
Yeah, but
yeah.
the brute force also you only compare with the valid candidate, right?
Brute
So
force would
brute
be
force.
also n square itself.
yeah.
Yeah, right.
Because you're
No,
comparing
Yeah.
each and
there
everyone
you are
with
doing
everyone.
more actually.
Yeah, yeah.
Yeah. So the thing which is saving this is this condition less than equal to num. This
Actually,
is what the
in
difference
the
is.
discussions, people have came up with since we are using an array, people try
Mhm.
to use binary search on the array to bring this from n square to n
But
log
it's
n.
not sorted, right?
Excuse
No,
me,
it
sir.
is a decreasing stack.
It is sorted.
Inside the
Excuse me,
stack,
sir.
it
It's
will
a
be
decreasing
sorted
stack,
because it
right?
is decreasing.
Okay,
Yeah.
this part you're telling. Stack.
Yeah, the stack is a decreasing, so people try to use
Okay,
this
okay.
binary search and
Yeah.
find.
Sir, excuse me, sir.
Yeah.
Yes, sir. I have done this in log of n, sir. Could I explain that?
Yeah.
N log n or log n?
Just stop.
Log n. Sorry. In of one, of n.
What?
Okay,
Linear
of n.
complexity.
Okay, sure.
Oh, great.
But actually, yeah, before going to that optimized version, so is the brute force clear now, right? So we're just comparing each element with each and every indexes of the other elements, right?
Right.
So,
Yeah, but with the brute force, I would use like the two pointer, one from the left and one from the right. And you move the
Right.
right pointer until you see that greater than equal the left one, right?
Then you break.
Yeah. So you don't, that's
Actually, you wouldn't
No,
call it
that's
like
right.
two. It's not 2 pointers.
but
You
then you are
would
having
take.
I'm sorry.
Yeah, sorry.
So in the two pointer, Leon, so are you going to sort them before you start using a two pointer?
no, you don't sort them. You
I
just
think
keep
if
it the
we
way it is
sort, there
because
won't be any sense.
what they looking for is the larger next okay, let's say the latest larger element, right? Not the first one, but the last one, the last larger element. So we just look for from the right.
Oh, so
I
you're
think
saying you move left. For the first left, you start from the right, completely come to the left, and then again move the
right.
left, and again come from right to left, something like that, right, Leon?
Right. Yeah.
Oh, okay,
But
I got it.
but
Yeah, no problem. Sorry,
And
go ahead.
So
sorting will
it's like
disturb the
order of n
orientation.
square solution.
yeah.
Brute force approach, right?
Yeah, that
Right.
would be out of n square.
Yeah, I think n square would work here because the array size is 10 to the power 4.
Actually, it didn't work.
It'll not work. Yeah, it'll not work.
Yeah, I've tried
But
that.
as per the
I've tried
constraint,
it too.
it says that it's 5
Like
into 10.
this was the
It's
brute force, right? This solution.
Yeah.
Like I first,
Yes.
I used
That's the
this
brute
thing.
force
It
approach.
showed
Oh,
this
so yeah.
time limit exited thing.
So Gaurav, this is the first one. What you showed was brute force, right?
Brute
Which
force.
is the
Yeah,
two
right.
pointer what Leon was describing.
Yeah, exactly.
Yes.
Okay.
So
This slight
let me basically start with the most naive approach, that would be the brute force approach, and I would explain my solution in a step to make my brute force better, and eventually we'll come to the optimized one of log n, right? So this was my first approach. Let me tell you this. So basically I did the same naive approach. I first ran a loop throughout this array, and I started by checking out each and every 1 second.
I think we got this. We can move to the next. If
Yeah,
everyone.
no. Basically, I have optimized this solution in a bit manner. Like you could say, I have changed this one to answer. Like if you have got my point, let me explain you from this example only. Like I have done this thing. This was, yeah. So let me tell you this modification thing. Okay, so when I started iterating over this loop, over this array, uh, I check for 6. I get to see that there is let me, yeah. I check for 6. I get the answer. I get this required, element at this position. So for this, my size, this would be my answer up till now, right? It would be 6 minus 0. So when I check at 6 at 0, I have to check, I don't have to iterate over 8, 2, 1, 5, and 6, and 5 also, because uh, because my answer for this my answer would be relevant if it would be more than 6, right? Because my answer up till now was 6. So if I check for further elements, I will have to check whether my answer would be greater than or equal to 6. So what I do, I check from uh, 7 only. I check from 5, and with 5 and 4 I skip the elements in between them.
Yeah, that's very good
Yeah,
idea.
that's good. Yeah.
Yeah.
Answer plus 1, right? I mean, you have already got answer. It would be
Yeah.
plus 1, right?
No, why would I, I have to, for this, my answer was this much space, 6 minus 0. So when
Yeah,
I go
6.
to next, I have to start from the number itself, from the number. If I increase
No,
I by
yeah,
1,
true.
then I have to increase.
No, true. But I was just saying that you have already got answer difference array. So
Yeah.
you could have started with answer plus 1.
Yeah,
I mean,
yeah,
you are
yeah,
trying to get the
that's right.
next
Yeah.
value. That's what.
Yeah, that's right. I could have done that. Yeah. So this was my approach in the brute force. Like I little bit increased, modified with this thing. So now what I have to do, my basic, the basic reason behind my complexity, runtime complexity getting increased is that after this also I have to run the loop. Like if there is this for these rest of the elements, I have to run through this much space, right? So what I've done, I'll make one more array. Let me take this one only. So, okay, so I take one more array, and I'll start, like I'll first keep the rightmost element of this array, uh, you know exactly to the rightmost element of our original array. So it would be 6. Okay. Yeah, it would be 6. And what I'll do, I'll keep account of the element which is the maximum up till now in the rightmost part of it. So for 1 it would be 5, for 2 it would be 5 as well. Yeah, it would be 5 as well. For 8 it would be 8, because the number which is greatest up till now, up till now, which is greatest in which is greater or equal to 8 up till this much of array is 8. And for 0 it would be still 8. For 6 it will be 82, right? Okay. So what I'll do, I'll take now 2 pointers, I and J. I'll take 2 pointers, I and J, and with I, I'll run, I'll iterate over this array. With J, I'll iterate over this array. Okay. So let me come to this. Yeah. Yeah. Okay. So what I will do, I'll start iterating over the from first element. Okay. So what I will do, I'll just check whether uh, whether my given, the element which is uh, greater than 6. I don't wait.
So you are taking the right index in the second array and the left index in the original array, right?
Yeah,
No, he's
it's
taking
the
right.
maximum right.
He's taking both the same, like from the left is starting, right?
Yeah.
Yeah, starting for both, that is from left.
The right index is iterating in this max right array, right?
Yeah. Right.
Oh, okay.
So
the array side name is max right. Okay.
Yeah. So what I'm doing, I'll start running this J over this array, and I'll at the same time I'm checking whether my A of L is greater than max right of R. So it should be it should be R and it should be L. Okay. So what I'm doing, I'll iterate over this array. I'll do this thing. I'll do this thing. Okay. And as soon as I come to this, I see that my A of L is greater than max right of R. Max right of R. So what I'll do, I'll just increase this L to 0, and then and then I'll keep checking the time till which this condition exists. So it exists. So
Till it breaks, right?
yeah, till it breaks, till it doesn't satisfy the condition.
Something number which we get minimum number.
Yeah, this condition.
Yeah, got it.
Yeah. So had there been like it's, I guess it's
-1, let's think.
let's say,
it will stop.
Yeah. So
After 5 you can keep 0, I guess.
Yeah.
In the L array.
So,
sorry, in the L part.
Yeah, here.
After 5, yes.
Oh,
so,
yeah, okay.
Now the condition breaks.
Yeah. It'll break here. So it will go up till here, and as soon as sorry.
I feel like 0 should be here and -1 here.
I don't think so. We have -1 because the values are all 0 and above,
but,
so it will be all positive values.
As he was trying to explain break condition, right?
Yeah, okay.
Yeah, I was just trying to explain this.
Yeah, I think this is pretty clear. Yeah, that's right. So you are actually creating a max right, which is the maximum values from the right side, right? That is what the cumulative maximum values from the right side, and then you are trying to compare those with the current array, right?
Yeah, right.
Okay, yeah.
Right.
That makes sense.
This would be then 9, 6, 1. Yeah. Okay.
Yeah. So if you start comparing the first 7 with 9, okay, though they are on the same index, right? But so it will be still 0. Yeah. Then you go to because then you will increase R in this case, right? So because
Yeah,
you are saying,
what it is basically saying, like for 7, the greatest answer, the the part which is greatest in up till now is 9. So it is basically checking on every index whether this condition is still there or not. If it is not there, it'll go to the next element and it will check whether it is greater than 7 or equal to 7.
yeah.
Had it been like this, then it will still run over up till here, right?
Yeah.
Because it is checking whether the greatest number up till the respective index, if that is greater than or equal to it.
Yeah.
So up till now we have been here. So then it will check with 0. For 0, we will skip this part. Why we are skipping this part? Because of the same condition, right? Because of the same condition of
because we have already calculated the maximum now. So if when it starts from 0, it's going to be lesser value. The answer will be lesser, right?
Right.
Yeah.
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 So then you move to 1 and then you finally exit the.
Yeah.
Yeah, exactly. So for 0, the answer, this R would go to then this, because this one also satisfies this condition that 1 is greater than 0, right?
Yeah.
1 is greater than 0, and at the same time we are also keeping a check of our answer, that which one is the greatest up till now, which one is the maximum up till now.
Yeah.
So for now, till now we have answer that is 6 minus 1. Okay, so the answer is 5. So now what we will do, we will go to the next element 9. We see that
you wouldn't go to the 9. You'll simply move
sorry
out of right array.
sorry.
So that will be
Yeah.
an exit condition
Yeah.
because we already got the answer, right?
Yeah. So for in this case, we will only iterate over only one time, right?
Yeah. So it is O of n solution. Yeah.
Yeah.
Now, this might be an optimized version, and also we are just using O of n space, correct?
Yes.
Yeah.
Yeah.
Yes.
Yeah. So you got a better timing also in lead code. Okay. Yeah, makes sense. Yeah, that's a good solution. Yeah.
Yes.
So any questions on that approach? I think that was most optimized version I could even think of.
Yeah, exactly.
Yeah.
And optimize it.
And what Nandini was also showing was much better than the brute force. Yeah. So we actually discussed about 3 approaches, and I think we also discussed with the stack, monotony stack that Shashank was discussing, right?
Yeah.
You want to share your screen, Shashank?
It's same thing. I think what let's I'll show you.
Okay.
So it's like I'm using a monotonic decreasing stack, and I'll keep the index of those elements. Like first time 6 I'll enter, 6 is empty. Next time 0 is less than 6, though I'll enter the index of 0. But now you can't enter 8, 2, all these things you can't enter. So in your stack index 0 and 1 will be there, right? After that, I'll start next loop, which will start from here, right of index. So one thing I made sure that this index will always be greater than the indexes which are present in your stack, because I'm starting from the right. And I'm just checking if this element, the right element, is greater than the top of the stack. Then just take the difference of those two indices, the indices which is at the top and this index, and just keep on maximizing.
Okay. I think, yeah, this is a good solution though, but Leon was having about the time complexity, right? He had a question about on the similar problem. So what is the time
No, I
complexity you
think
think?
In
this
square
one
it
is
will.
better, I think so.
I'm
No,
sorry?
this one would be n, right?
Yeah, I also think so.
I was thinking this one would be n because you are trying to pop as well.
Right.
But inside that I'm using as long as stack, right? This one.
But you will
So
keep
Yeah,
on
if
popping.
stack is empty, you will not do anything, right?
Yeah, only then it will be order of n, right?
I was
Yeah.
thinking it's sort of, and I'm not sure.
So
Yeah, because usually it is almost like a monotonic stack. So the monotonic stack implementations are not elsewhere.
basically,
uh,
in the worst case, you'll be visiting the same element twice, right?
yeah,
So once you have popped it out of stack, you will never be visiting it again, right?
definitely because yeah.
So I think it'll be like n only. Worst case, it'll be 2n.
Hmm.
Yeah.
Which will boil out to order of n only.
Yeah.
Yeah.
Okay, so maybe you can check this again and let us know. But I think it is almost O of 2n or something like that, but not O n square.
Because yeah, it should be because first for loop I'm just inserting all those indices. I mean the decreasing stack, decreasing element indices. Next time I'm just traversing from right side and checking if this element is lesser than the top of the stack. So yeah, it should be. I need to do something like let's check it and then I'll update it.
Because you are not going to use the ones which you are popping out, right? And
Exactly. Yeah. One pop
yours,
out.
yeah. I think
Somebody.
Harshit
Shashank,
shared something. Harshit, what's that?
I have shared exactly what Shashank has done.
Uh-huh.
This this might show that it is O of n only.
Oh, okay.
Oh,
sure.
I've shared in the chat.
chat. Are you able to see the chat? I'll show it.
Yeah,
Can
I
you
think
see?
it is exactly the same what Shashank is doing, right? But it's in a different language only.
Yeah.
Yeah,
Correct?
that's yeah.
Yeah.
Chalo. Can you share the solution to Shashank, please?
Sure, sure. I'll say after the class. I mean, we'll share
Yeah,
it.
yeah.
Or in chat, should I?
No, you can share on Discord itself.
Yeah.
Okay, okay.
Okay.
So shall we move to next or any?
Yeah, I think so.
Okay.
If anyone has any questions.
Yeah.
Okay, let's move.
So it's like first missing positive you have to find, and unsorted integer array is given, and first smallest positive integer we are supposed to find. Okay. Yeah. So it's like here zero is there, one is there, two is there, three is definitely you are missing, and here two you are missing. And it should, yeah, this is the core part. This makes the problem tougher, right? That your algorithm should run in O of n time without using, I mean, each space O of 1.
Okay, so we have to implement an algorithm which will run in O of n.
Yeah, that makes it bit intricate.
Okay,
Yeah,
so that is the most important thing. And he is saying also use constant extra space.
exactly. Yeah.
Okay, so no data structure, extra data structure to be used.
Yeah.
And then the question comes, can we modify the input array? Because if you don't have to use extra space, then that might be also a concern, right?
Yeah, that is the only way like you can then play with the array elements, right?
Oh,
By
okay.
modifying the elements. Yeah.
So you have to modify the input array, or else you won't be able to do it. That is what you're trying to say.
Yeah.
Okay. Or else,
So what?
if you anyway, if you can, oh, you are not going to return the array. So yeah. So you need an
Uh,
extra space to solve. Yeah, that's right.
yeah, yeah. Unless it's like passed by reference in ZFS. In that case, I don't think we can like update, modify the array, right?
Yeah, but still you are modifying that input array, because if that array, that passing reference, that value is being used by someone else in the higher up functions, it might be useless to that person, right?
No, I couldn't understand it. Sorry.
So if you are passing by reference and if you modify that value inside this function, so it will be
Right,
modified for all the values, all its
right,
values
right,
which are used by that function. So
right.
that is one thing to be always get it cleared from the interviewer whether that is allowed or not.
Yeah. Okay. Oh, I got it.
Yeah, it's of concern. We can
Yeah.
ask the interviewer.
But in this case, Shashank saying that we don't have any other way, we have to modify it.
Yeah. Or might be, I'm not sure, like what
Yeah,
I
that is what I'm also asking. Yeah.
So you're talking about modifying the array.
yeah.
Right.
There is no point. I mean, I think we can modify, but without modifying also we can proceed, I guess. Like if you take use of hash map and check what are the numbers which are present.
No, but
And
constant
We'll
is
take.
this one.
con- and
Note,
uses
note, your algorithm should run in open time uses constant extra space.
So if you use hash map, you'll use another extra space, right? So that is also not,
Allowed.
yeah, it's something at a constraint like.
Yeah, so it's a trade-off. Like
yeah,
we
yeah.
either don't use space and compromise on the time complexity, or we use space and make a complexity.
Let's first actually think about that. How can we solve it with the extra space?
Yeah. Can we first think about the brute force approach?
I think
So
it's not
just
brute force.
do like a map, like unordered map, something like that,
Yeah,
and keep on putting all these values as per their indexes, right? Or maybe use an extra array,
yeah,
and then
exactly.
as per that indexes, you keep on putting those values, and whichever values are fitting. So you'll have to use an array space of the maximum value what you have. It will be a bigger array also.
Okay.
And if it is a negative value, if you have negative numbers also, in that case, then you'll have to convert those negative numbers. You find the minimum and the maximum, and then use a bigger array of that size. So you also use the negative numbers in such a way you have some middle number, and then you convert that negative number to some indexes. So you'll have to do all those index manipulations.
Excuse me,
Okay.
sir.
Now.
Why we need to consider the negative number?
No, that is what he's saying. Like he's saying that you are allowed to use spaces, a brute force, what Praveen said. So that
Yeah,
I will
but
use the maximum array.
the question was asked for the smallest missing positive number. So if we see negative number, we can ignore it, right?
Oh yeah, that also we can do. Yeah, do a bit
Yes.
optimization in that. Yeah.
Yeah,
That is a good
negative
point, yeah.
numbers and all those numbers who have a value greater than n.
Okay, we can do
Right.
another optimization in that case also. You just move those two values, ones which are negatives and ones which are greater than n. So you use only a value of that, the value of the size of the array what we have. Okay, you can have a same value of same size of array, and now you are not
Okay.
storing the negative numbers and any number which is greater than that. Okay, so
Will
then
greater
it
than
becomes
n.
more optimized, right?
Excuse me, sir.
Yeah.
Sir, what we will do, we will start, start, we will first sort the array. So we'll first
We'll
sort.
get to that. We'll get to that.
Pardon?
Yeah, we're discussing the brute force.
No, then what I'm saying, first we will sort the array. Then what we will do, we know, we will find out the number of positive elements in that array, and then we will take the sum of that. Like we won't directly calculate each and every term. What we would do, we would just uh, uh, find out the value using n into n plus 1 by 2 for the sum of first
Yeah.
n numbers, right? And
Yeah,
then
Gaurav, yeah, I got your point. So that is good. Just a minute. Let me finish that. What do you say? The
Brute
brute
force
force.
approach.
Yeah, because we were just talking about. We'll come to that. You are correct. So I think this is clear, right? The brute force, what we just discussed. That's the only maximum thing you can do that. Correct.
Yeah.
Another brute force I'm thinking is like you put the number in a set. Like of course we can ignore the negative number, right? And now we just look from 0 to n, where it and then see if the number is not in the set, then that the first missing positive number.
Yeah.
Uh,
Good approach.
Yeah, that works.
Right.
But
Actually,
if we,
there is one more
I,
sum like contiguous. You need to find the contiguous sequence, the longest contiguous sequence, something like this. I think you can do the find the minimum of the positive numbers and use the hash map idea of Leon.
Yeah, that's good one. But could you be
Yeah, I
more
just looked
elaborate?
through that. 0 to n, right? It is consecutive, one by one.
So
I mean, some might be missing, right? So you could, I mean, zero. Yeah, you can see.
so Leon, when you say 0 to n, do you mean like indices 0 to n or the values at index?
No, the index from 0 to n, where n is the length of the array.
yeah.
Excuse me. Like I have this doubt whether there's only one number missing, or whether
So,
there could be any some chunk of numbers.
so we have to find the first missing, smallest
There
missing
can be
number.
chunk of numbers, but we have to pick the smallest one of all.
So, so the
So
thing
if we
which
take third example,
is not clear to me here that if you see the example 3,
yeah, example 3.
example 3, so here it says that the missing number is
The
outside that range.
Right.
Whatever
so
the number
it
we
is
have. So
traversing
it's
the natural number line. So the first missing number in the natural number line, that is our answer.
Right.
Right.
Yeah.
Yeah, the positive, so it begin with 1, right?
Yeah, right. So yeah, so the Uday's approach was okay, right? Did everyone understand it? Or Uday, do you want to elaborate more on that before we move on to Gaurav?
No, I think it is Leon's way itself. So just instead of starting with 0, I was saying the minimum. Take the minimum.
Yeah, now we see, start with 1 to n.
Okay.
Yeah.
Okay, just
If we
start with 1
start
to
with the
n.
minimum, it won't work for this example, no? The third example.
No, I mean minimum as in minimum positive number.
So minimum as 1, he's saying, yeah.
Which is 1,
If-
right?
Yeah.
So if minimum is already greater than 1, you could directly return. I mean, you don't need to do any access on the hash map or something.
Yeah.
yes.
Okay. Yeah. So, but that solution still is O of n with extra space, correct?
Yeah.
Okay. So we'll still good, but only we are using extra space. Okay. So then if we come to Gaurav's solution, yeah, Gaurav, go ahead.
Sir, actually, I misunderstood this question. So,
So
that's
I
why
have a n log n solution, but it's really bad. Like I have to do a lot of checks.
Okay. So you are sorting it, right?
Yeah.
Yeah.
I'm sorting it, and then I'm doing like
What is the
a lot of
approach for
checks.
the?
Sorry.
What is the approach for the? What after sorting?
So I can share my code. I can run through that because I have to take care of a lot of cases while coding.
Okay, go ahead.
Yeah. So yeah. Is my screen visible?
Yeah.
Okay. So the first thing I do is I sort the array, and if my array size is not, I mean, if it's 0, then I return 1. Otherwise, check if my first element is greater than 0 and it's not 1, so I'll return 1. And the next thing is, if my array is having size equal to 1, then I check these two things. So it's like a lot of checks. Next, I come to the part of traversing the array, where I'm taking 2 elements at a time. So if my num of I and num of I plus 1 are less than minus 1, then I just ignore them and move on. Now the next thing is that if I plus 1 is greater than 0 and this holds true, then I'm coming in this loop and I'm doing this. Like if my number is less than 1, I check if is the next number 1. Then I don't do anything, because in that case, the number in between comes out to be 0. So I move on to the other things, like the other next 2 pairs. So otherwise I return 1, because if it's not 1, say if it's more than 1, 2, 3, then the missing number is 1. And so the leftover case is when my number, the missing number is just nums of I plus 1. So that is here, and the other 2 things are like.
But on line 28, you say nums I is less than or equal to -1. Are you not already filtering that on line 22?
I'm not checking this I plus 1 thing, no.
Oh, okay.
So let's say nums of I is -5 and nums of I plus 1 is 2.
Okay.
So that is where I come in this loop.
Okay. Yeah.
Yeah, so I got this right by, I mean, submitting a lot of times, checking those test cases. So I don't think this is the correct way, but
okay.
yeah,
But you tried that, yeah.
Yeah. I was
Excuse
trying
me,
for
sir?
n log n solution
Without extra spaces, right? Okay.
without extra space.
Okay.
Let's see if improvement is from both folds.
Excuse me, sir?
Now we're saying
Sir,
still improvement from both folds.
Yeah, so this is okay, but it's an n log n solution. So we can still optimize on this solution, right?
Exactly, yeah.
Yeah, okay.
Yeah.
So I guess I have got the answer.
Okay.
Can I explain it?
Yeah, go ahead.
Yeah. So what I'm doing, I'm doing the thing like I am first finding out the minimum and maximum number of the array. Okay. It would be of log n complexity, right? Sorry, of n. Of n, right? It'll be of n complexity. I'll find the maximum and minimum. So maximum, what does that maximum thing signifies? Let me take one example. The example I guess they have given. 1 second. Yeah. So let me take this third example only. So, second example. In third example, when I see that my number by minimum number is greater than 1, I'll get the answer as 1. Okay. But in this in the second example, when I see that my this greatest number, and minded, I have to keep the minimum number positive. If in the case of example 2, my minimum number would be 3. Okay. So yeah.
Someone sharing the screen? Yeah, Gaurav. Yeah.
Actually, I've just now, find out this.
Okay.
So, so I take maximum minus the number. I first find out the number of elements. Okay, maximum minus minimum.
How will that give you the number of elements? I mean,
the number of potential elements, I think you're trying to say.
No, I'm first finding out the number of elements, number of positive elements. I'm finding out the sum of number of positive elements first. I'm taking the sum of positive elements, and with the help of maximum element, I'm using that formula of sum of first n numbers. I find out the sum of the had there been first positive n numbers, that the sum would be that ideal sum. And in this case, my sum from positive, from minimum to maximum, one number would be missing. So when I calculate that sum from that minimum to that maximum, and after calculating that sum, when I subtract that from this, from my
I think can we just write it on the screen? You know.
yeah,
I think
Yeah.
it
That.
won't work.
Yeah. So then it will be clear.
Yeah.
Is it visible?
Yes. Yes.
Yeah. So 1, 2.
Take this example, the second example only. Okay.
Uh,
I'll just let you know what the input is. It is 3, 4 minus 1, 1.
One second.
Yeah.
Yeah.
It is 3, 4 and minus 1 and 1. Yeah, you'll have to change that. Yeah.
It is 3,
3,
3,
4,
4
minus 1 and 1.
and 1. Okay. So yeah. So in this case, I take only positive numbers. So it would be my maximum number. First of all, my maximum number, positive maximum number, would be 4, and my minimum would be this
1.
3. Sorry, 1. Yeah, 1. So with this 1, I'm assured of the thing that answer wouldn't be 1, right? And for this 1, for this 4, I say, had there been first 4 positive numbers, the answer, the sum of the first positive numbers would have been n into n plus 1. Okay.
10.
Yeah. So by this, I'll get the answer as 10. Okay. But the answer right now is 8. So I'll subtract this and I'll get my answer.
So if instead of 4 it is 6.
Yeah.
Yeah.
No, but that won't be the case. I have just now gone through the possible explanation of this question. The main thing that they have done, that in the starting also, I only asked that could there be the possible case where there could be there could be chunk of numbers missing. There
Yes,
it
that
is
is
written
possible.
that but that's the case only like of that third kind.
No, it can be like 3, 7 minus 1, 1. That is possible.
No. I've checked. I've just now been through the discussion part and all those things. I was
Stick to the question.
skeptical to that thing only.
I don't
but
think so.
I mean,
I think
I
it's
don't think
possible.
so. Yeah.
I've just.
He just wants us to find this first positive missing number.
Okay, wait. Let me write this solution. I guess that after this.
Yeah.
Okay, so are you saying that this won't work for if we have more than n number of missing positive numbers, right?
Yeah,
right.
basically there's a non-continuous sequence.
Yeah. So if it's only
it
one
won't work.
missing number, then it will work, correct?
It will not work with example 3.
Yeah, it won't work. Yeah.
No, it will work, right? Well, what I'm saying, I've just now calculated my minimum number. For minimum number, my answer is 7. It is greater than 1. So I'll just return my answer this to 1. I'll return answer 1 if the minimum is greater than 1. If it is not greater than 1, if it is not greater than 1, if it is this case, like my minimum has to be 1.
Okay, so you're going to do other checks also along with this one. Okay, yeah.
Let me do this thing, right?
So let's say if we include 1 in that example 3.
Yeah.
Will it work?
So it is 7, 8, 9, 11, 12, right?
Let's say 1, 7, 8, 9, 11, 12.
1, 7, 8, 9,
11, 12.
Yeah, that's what I'm saying. I'm saying that as far as I have understood the question, it's like there can't be a case where a chunk of numbers are missing from 1 to n.
But
It'll be only a case
where
of,
did you read this?
yeah,
I
Yeah.
I
So
just,
yeah. So as per the question, I mean, any number of
yeah.
so
Yeah, but that's
it's
a
not
good
just
point.
one or two. Yeah.
Right. That's a good point to discuss with the interviewer, because this is an ambiguous one, right? It's not clear from the problem statement. So you can assume that also.
right, let me write the code
So
and
it passed all test cases with the solution?
no, I've just now,
He just came up with this. He's trying to
Okay.
discuss, I
Okay,
think.
okay. Yeah.
That's good. We are just doing the brainstorming.
Right.
Yeah.
So it will surely work if there is only one number missing, correct?
yeah.
Yeah. Yeah. So that was a good discussion. So anyone wants to come up with the right solution? So can we discuss that, Shashank?
Yeah, I haven't implemented actually.
So could we modify the array?
Yeah.
We don't use extra space.
Yeah, we have
Yeah,
to
I think
modify that. Only
Yeah,
way
let's
to-
try that.
So I'm thinking that we can use the index
Right.
of the array to mark that, if we have that number or not.
Yeah. So do you want to share the screen?
No, I'm only thinking that way. I haven't implemented yet.
Okay, then I'll just share it.
Actually, my answer would work in this one. Sorry.
No problem.
Yeah. It would be this one. Yeah.
That's fine.
Okay, you are saying that it could work for the other example, right?
Yeah. Because in that they have specifically, mentioned that thing. This find the one that is missing from the array.
Yeah. So then that problem will become easier also, right? That is what they have
Yeah.
mentioned.
Yeah.
No problem. That's good. Yeah. So Leon, the way you are saying, so if we take the second example, 3, 4 minus 1, 1. How do you want to go?
Like at 0th index.
And
So
we have 0,
we
1,
see,
2,
yeah.
3.
So we see 3, right? And then I think we need somehow mark that, index 3 is already visit. If it's out range, we will ignore it.
So range in the sense our size,
like
max
4
size
right here.
is
Yeah.
4, right? Yeah.
So let's see, we just see 3 right here, right? And then we look at, okay, within the index, so we have to go in and somehow we have to mark this one. I think it maybe first we have to find the max.
Okay.
I think
or we can module by find the max value of the array. And then to mark it as visit, we can add the max value to 1.
You want to change this value to 1? To 4?
Adding 1, you say, I think.
So in this case, the max value of the array is 4, right? So 1 plus 4 gonna be 5. We put 5 there.
Okay. So you are saying I'll put a 5 value here. Okay.
Right. And 4 is already, out range. We forget it. -1. We forget the 2. We ignore the 2. Now we go to 1, right? So
but we have already modified that.
Why did you
No, we
discard
haven't.
Oh, so you want this to be modified then in this case?
Right, yeah.
Okay.
So we see 1, then we add, add 4 to add 4 with 4 gonna be 8. Yeah.
So this one, what do you want to modify? The 1? It will be
So
5, right?
at index 1, right? Yeah, that one 5. Now we see we visiting the last index, which is 1. That means now we have to go back to value at 1. We add 4 to it. Now it become 8.
Yeah, so
Right, 4
now
plus
you
4,
want
8. Yeah.
Oh, so this one 8.
Yeah. Okay, so we're done with the pre-process. Right now we go back, iterate from left to right, from 1, probably from index 1, right? And then we see it at index 1 we have 8, which is greater than max value. So we know that this index already exists. We move to the next one. Now we see that that is 2, right? And that's a negative, then we're going to use it. That's the answer.
Okay. But I think I missed up here what you said. Okay. Okay.
I have a somewhat similar approach, but it just a little differences between how I'm marking and how Leon is marking.
Okay. Yeah, let's finish this, then we'll come to yours.
Yeah, sure.
So, Leon, this is done?
Yeah. Yeah.
So any questions on this approach?
Okay, and to restore the original array, we just walk through that again and mark each value by max, so we can get back the original value.
Okay, you want to subtract each one, so you again bring that one. Okay, that makes sense. Yeah. So you're not going to destroy it also. Yeah, good.
So could you repeat again? So the part which is not clear to me, that so if I understand correctly, so first I figured out that what is the max element. So in the original array, right?
Can we redo it again? Yeah, quickly. If you don't mind. Okay, just give me a minute. I'll just erase this. Because I also got confused exactly on what he said, and then I messed up. Okay, Leon, let's start. So max value is 4. So what do you want me to do at the 0th index?
Yeah, so we see that 3.
Okay.
Right? And then we have to go to index 3.
This one, right?
Yeah, we add 1 to it. I mean, you add max value to it. So now 1 plus 4 equals 5.
So Leon, I do have a question here that you are jumping based on the value, right? At that index.
Right.
That you can easily go out of the range.
He's going to check it. If the value is greater than that, he's going to ignore it.
Yeah, if the value is greater than the range, then I will ignore it. And if the value is negative, I will ignore it too.
Okay.
But I see one potential problem because I modify the value, right? And later when I get there.
In example 3, so it will go for all the index, it will go out of range.
Yeah, so then you'll have to keep some flag saying this has been modified and something like that, So I am slightly doubtful about that.
I think for that, the first 2 things we should do is that we should somehow get rid of negative numbers and all those numbers greater than that.
Yeah,
exactly.
No, we don't need to get the negative number, right? Because we can keep it there. So when we go there, at the last iteration, when we go there, and if it's negative, we know that, that value, we can use that value for the answer.
Because, if you remove the negative numbers, because we want to use each and every value first. We want to find if they are actually fitting the correct space.
Yeah, but if we remove the negative number, then we cannot restore the value, right? We would don't
you
want
cannot
to
restore. Yeah, that is true. So yeah, it will destroy the input. That is for sure.
Yeah, that is for that is there.
Yeah.
But, just keeping a number negative shows that we have modified that index.
Yeah. So my purpose to keep that to modify the index being modified is to add the max value there, right? So that by adding the max value to the value at that index, we know that value have been visited.
Yeah, but in the case again, you don't know whether when you come to that place, you don't know whether it is modified already or the value itself is a bigger one, right? So
You can mod it by you can subtract it by the max,
No,
right?
but now
To
see,
get a
in the case 4, so how do you know that whether it is modified already or you have modified it on your own? So that will be a case, right? So you don't.
Okay. I mean, for time being, let's say we can modify the input and we don't need to care about whether to revert
Restore
it
its
back.
value.
Yeah.
So if you can modify the input, you don't have to restore, then the best way would be, I think someone was saying, right? I didn't see, was it Harshit or who was it? Ronnie, Harshit or Shashank? So you want to go about that approach, right?
Yeah, which is much similar to round one.
Okay. So okay, I'll
yeah,
stop this.
I'll just go ahead. I mean, we can do it on this only.
Okay, go ahead.
So what I'm doing is, in the first place, I'm getting rid of all the negative numbers.
Okay, what do you do about negative number?
I'm just setting them n plus 1. So in this case, minus 1 will be set to 5.
You want to set this to 5?
Right.
Okay.
Because let's assume the numbers are 1, 2, 3, and 4.
Okay.
Then in that case, so even in that case, the first value will be missing value will be 5, right?
So any negative number, you are just going to override that as a value as 5.
Yeah.
Okay.
Yeah, exactly. N plus 1.
Okay.
So in the next step, what I'm doing is, in the next step, I'm iterating over all the numbers.
Okay.
And I'm simply marking the numbers.
Mm-hmm.
So basically, I go for when I equal to 0, the number is 3. Then we'll mark the index.
How do you mark the index?
By marking, I mean we'll turn it into negative.
So you will turn this 3 into negative 3?
Yeah.
Okay.
So basically, 5 will be not 3 into negative 3. I will turn 5 into negative 5. Because index will be this, right?
So, okay, the 2, you're actually going to make this as negative 5, correct?
Right. Yeah, exactly.
So
now
you're
5
changing
will
the
be
value of index 3, right? So shouldn't it be 1?
I mean, index 3 minus 1.
Okay.
Index 3 minus 1.
Because I'll have to adjust for 0 as well, right? Index starts from 0, so negative 1 for that.
Mm-hmm.
Okay, so you are going at that index and marking the value negative. Okay.
Right.
To make sure that that number exists.
Exactly.
Okay.
So at the end, the unmarked index would be.
Okay, let's walk through the whole example here. What do you do for this one, man?
So
okay, then we are at 4. Then we'll mark index 3 as negative, which is now it will be minus 1.
Okay.
So 4, you come here and you mark this one as minus 1. Okay.
Right.
Okay.
So now when we are at 2, which is minus 5,
what
we'll do is we'll take absolute value of all the numbers and not just the value. So we'll take absolute value will be 5, then subtract 1, which will be 4. 4 is greater than n. 4 is greater than equal to n, so we'll skip it.
Okay.
Right. Then we are at now index 3. The number is minus 1. And we'll take the absolute value, which is 1. We'll subtract 1. Now we are at 0. So we'll mark the index 0. So now 3 is marked as negative 3.
From what you are subtracting 1?
Shajan, what are you saying? This one, right?
Yeah.
Yeah, I mean, he got the absolute value of minus 1 as plus 1 after that.
Yeah, I'm subtracting from that absolute value itself.
So the absolute value is 1 here. So he's subtracting 1 from that absolute value to make it 0.
Yeah.
So
this
then
is
it's
the
going to
index
that
which
index.
I'm supposed to mark. Right. So now I'm just simply turning that index into like the value at that index into negative.
Okay. Then you come for the second iteration again, right?
Yeah. Now I come for the second iteration in this and this. If the value at this index is greater than 0, which is if it is positive, then the answer will be I plus 1. If otherwise, let's assume all the indexes are marked. In that case, the answer will be n plus 1.
Okay, so in this case, you are at a 0th index, it is -1, -3, so you are going to ignore it.
Skip.
Correct.
Right.
Then you come to 1. So you
Right.
see the value is
4
positive
greater
value.
than 0.
Yeah.
Right. Then I'll simply return I plus 1.
Okay. So you will
I is
find
1,
that.
so
Okay. Okay. Got it.
Yeah.
So how your approach will work with example 3?
Just a second.
Okay. Okay. Let us
So
take
in
that
this
example.
case, in this case, since all the numbers are greater than like n, so n is here 1, 2, 3, 4, 5, right? Since all the numbers are greater than n, so I'll just simply skip all of them. And in the second iteration of the for loop, we'll see if the value at I equal to 0, it is 7, which is greater than 0, which is a positive number. It means that this index is missing. So I'll return I plus 1 simply.
Oh, so what you will do in this case? 7, 8, 9, 11, 12?
Yeah. So since so in the first for loop, we'll mark all negative numbers into positive by turning them into n plus 1. Since in this case no number is negative, we'll skip that part. Then the second part is we'll check for all the values. We are supposed to mark in the second part, right?
Yeah.
So
here
we'll
itself you will
see.
get. Okay.
Okay.
Exactly.
So if the value is out of bound, then you will skip
I'll
that
simply
too.
skip. Exactly.
Okay.
I think the first check should be we should check whether 1 is present or not.
I mean, it doesn't matter because it will be handled automatically, right?
Yeah, I mean, we cannot say that. I mean, 1 present is not. If 1 is there, 2 is not there.
Sorry.
Then it could be 1, 2, 3, 4, 5, and then 7 is missing, and then 8, 9, 10, 11.
I'm not sure I follow you.
No, I mean, someone says that. I mean, just check that 1 is available or not.
Oh.
So I'm just saying that. I mean, that will not work if we just
So
actually
I'm
rely
saying
on that
the
one.
first check. I mean, the first check. I'm saying.
The very first check is saying if the index or maybe the size of the array is only 1, right? So in this case,
That also, and if there is no occurrence of 1 in the array, then 1 would be our answer.
Yeah.
I think it will be handled in these 3 parts itself only. So we don't have to explicitly check them.
I agree.
So he's done is slightly different. Yeah, that is because the solution describes a different way. It's a lengthy way, and I think this was the shortest way of doing it.
So did you try to submit that, or are you just explaining it here right now?
Yeah, no, I have submitted it.
And that worked.
But changing the negative to positive with the same as create extra space, right?
Right.
Then
Right.
we should use the set to solve it or some other approach to solve it. I'm thinking my approach would work. The one I proposed initially.
The set
because,
one?
Yeah. No, not the set. Not the set.
Can I say something?
Use the go ahead.
Sorry, why don't we do simple way of like sort the array? Okay, sort the vector and start with min is equal to 1. Like you start with min and go each element by element, search whether there is a min. If it is equal to min, then increment the min, and then again go through the next number, right?
I think we discussed that, yeah.
Yeah, we discussed that.
Oh, okay.
It's n log n, right? So we want to have some solution to be O of n with constant space. So that is what we came up with here now.
I think this solution use negative to mark it, as visit. I use I add with the max value to mark it at visit, right?
Yeah,
and I keep the same negative. But that one, I think if we go back there, I think it worked.
Yeah, it might work, but the only concern what I had, if you are marking some number, making it a positive, bigger number, when you come to that number, you never know whether it is a modified one or the input itself was the same.
Yes.
Right?
So
you won't be able to differentiate that number.
Right, but it doesn't matter because, as long as you mark that with the max value, you will know, right? Let's say, can we go back to that problem? We can work through that.
Okay.
So the 3, 4, negative 1, is that? Yeah. 3, 4, negative 1 and 1, right?
3, 4, yeah, minus 1, 1. 4 is the max,
So,
yeah.
can we write the index in front on top of it?
Okay.
Yeah. So the max is 4, right? We go 3. Right now, the first is 3, so we go index 3, right? We mark 3 as visit by add 4 to 1, so become 5.
Okay.
Right? So we go to next index 4, which is outbound. So, skip it.
Okay.
Now we go -1, which is, outbound too. So we skip it. Right? Now we go 3. Value is 1. Right? That means we have
value
to
is not
add,
1.
No. Yeah.
You modified the value to 5.
No, but then you can mod 5 by the max. Now you get back 1, right?
Oh, so you want to do it? Then why did you do it for 4 then in that case?
Because we already there. We iterate from left to right.
No, that is
right?
true. That is true.
Yeah.
So when you came to 5, okay, when you came to index 3, you said 5, you can do a mod of 4, right?
Right.
But why not before, when you are at this position itself, when you are not traversed till this position, here itself, why didn't you do it then?
Because
the 4,
it's
why?
outbound. Because it's outbound.
Okay, but
right?
then when you come here, then why it is not out of bound, this 5 value?
Even
How do you
if,
differentiate
okay,
that? I'm not able
even
to
let's
get
say,
that.
right, even if you do it as 4, if you mod by max value, what you get? You get 0, right? Right? But because it's outbound, so you can ignore it.
That is correct. But when you come to 5, why you act, your actions are why different? Because there might be some way to do that. I'm not saying it won't be possible, but I'm not getting it. You get what I'm trying to say? Because the way you are
Maybe we can
actually...
Yeah, maybe we can go on another example.
Okay.
Maybe that, we can, anyone can come up with example.
Okay.
Because
Yeah.
all we do is like we mark it, at visit by adding the max value to it. It's the same as.
Okay, let us take the very simple example, the 1, 2, 0 example, right? Your maximum value is 2 in this case. So what do you want to do?
So let me see 1, right? So the max value is 2. So we add, we go to index 1. We add 2 to it. So now it change to 4.
So this will be 4.
Right? So we go to 1. Now our current is 1. Now 2, right? The index is 2. Right? So we go in there.
So you actually mod of 2 here, right?
Yeah.
Okay.
Add 2 to that. Right? So
add
now
2
it
to
becomes
this one, right?
Yeah.
Okay. Then you come here.
Right, 0. So now we, add 2 to it, now become 3.
Okay.
Right? Right? So we walk through it and we see which one already visit. Right? We see if 3 greater than max, right? Visit. Oh, did you erase this value? Yeah. This one before was 4, right?
This one?
What,
No, this
what
was 2
value?
always. It was 2.
Yeah.
Because it was the legitimate value, right? Max 2. So we just said 2 of mod 2, which is 0, something like that. And then you went to this.
No, we add 2 to it.
So you add 2 to the second index,
now
right?
become 4. Yeah. They become 4, right?
So this one you want to make it 4?
Yeah.
Okay.
So we go in here, we see it greater than 2. So we know it already visit, right? And we go into 2, the last index. We see that also greater than or equal to that 2. We know that already visit.
Okay. So what answer you want to return? So now you have 3, 4, and 2, right? So what do you want to return?
Just max 1 greater than maximum. Immediate greater than maximum.
So add 1 to the max.
So you will say 2 plus 1, 3. Okay. Yeah, I'm not saying it might not work, but there might be some test cases you'll have to take care of properly.
Right. Yeah.
So I think implementation will be
Brainstorm.
more tricky. So therefore, I think it was Harshit or Ronnie who will discuss the earlier problem, because I can see the name now. So that was very, at least understandable to some extent, and quite easy to implement to some extent. I'm not saying that it's that easy, but it might be possible to implement. But this one will be very tricky in an interview to implement.
No, I'm just
It might be
saying
possible, at least for me, I'm saying.
The
Something
way I
like
see is the previous one is marked negative as visit, right? Now,
Yeah.
if we have different way to mark it as visit, but still preserve the negative.
Agreed. Yeah, so you're trying to preserve the value of the input array, and that's a good thing. Yeah.
No, but you can reward the you can modify the array after getting that number, because what he was actually doing that for the negative value, he actually incrementing after the max value.
No, I think he was actually destroying them, right?
Actually,
And later I can restore it by mark every value by the max. I can restore it back.
Yeah, in this case you can, but I
No,
think the implementation will be very tricky.
Even in that case, we can restore the array, can't we?
I don't think so. He has done it.
No. Yeah, I think
so
we can.
we can restore the array easily.
I think
But I think
it was Ronnie or Harshit who, I'm sorry.
So can I do some modification in that approach only, like I have done now that thing, but yeah, yes sir, can I show you my approach? Can I tell you my approach?
Yeah.
The previous solution that we were discussing, in which I was like replacing it with num plus 1, we can restore. We can restore the array, but we'll have to check like the formula for restoring the value from that like particular index or newly created value that could go out of bounds of the integer length. So integer flow will have to handle.
Yeah. So I also saw in the solution, actually they completely destroy the array, input array. So it was difficult actually to get back to the original state. But actually the way Leon is saying, yeah, it makes sense. It might be possible, I'm not saying, but I don't think so it's easy implementation. You'll have to consider all the test cases, right? Yeah. Okay, sorry, go ahead. Yeah, sorry, Ronnie, go ahead. What do you want to say?
I'm not sure about Leon's approach, but I can share my code. It looks pretty straightforward and not that complex to write.
Okay. So let us finish what he is saying.
Yeah.
Good.
Yeah. So what I've basically done, I have, I've taken two cases which are of no use. Two types of elements which are of no use to me. I have firstly, my first case of elements are those of negative numbers. What I've done, I have cancelled out each and every negative number and replaced them with 1. And the second case of number which are of no use to me are those which are greater than the bound. You could say like in this we have we have 9 numbers, right? This is a set. This is an array. This is an array of 9 elements. So any number which is basically greater than 9, which is basically greater than 9 is of no use to me. Okay, so such type of elements, it is 20 is one of them. So I have cut this element 2, and 0 also. I have cut 0, negative and 0 elements.
So what are you doing? You are cutting in this. What are you doing?
Yeah, and I'm replacing them with 1 only. Okay. So yeah, perfect.
So this is your other solution, not the one what you are describing, mathematics solution.
Yeah. It's another solution. It's a totally different solution. So okay. So what I'll do, I'll start iterating over the from the first element. I'll go to first element. I check it is 8, and 8 minus 1 is index 7. This one. I go to this index, whatever is the value, I take the absolute value of it. I'm not negating it. It's not like whatever be the value, I'll just put a negative sign in front of that. I am first taking the absolute value of it, whether it is negative or it is positive. I first am taking that absolute value of it and putting a negative
It
sign in
cannot be
front of it.
negative, right? After you process them, everything is at least 1.
Sorry?
After the process you did, everything is going to be at least 1. So it cannot be negative.
Yeah. Minimum will be 1.
Yeah, he was just saying, yeah, you're right. So it's going to be 1. It's not negative number. Correct.
Yeah. So I'll just put a negative sign in front of it. Sorry, it will be here. Okay. Then I go to next element. Next element, I checked its value. It's 1. I go to that index. 1 minus 0. I go to this index. I put a negative in front of. I put the absolute value. I take the absolute value and put a negative in front of it. And then I go to this second. I go to this. Here it is 4. 4 minus 1 is 3. It's this index. I put a negative in front of it. I go to this element 3. 3 index. 3 index value is minus 3. I take the absolute value of it. Remember, like every time I'm saying that in the original, after doing all this cutting and all this such things, at the in the end we have only negative values, right? In the all the positive values. So when I go to this 3, I see there is a negative number, and still I'm taking the absolute value of it. I go to I deduct 1 from it, and I go to that index. It is 2. I again take the absolute value. I put a negative sign.
Mark negative. Yeah, okay. So you're trying to mark negatives for whatever the values indexes are, right?
Yeah,
minus 1.
The indexes which I visited.
Okay, no problem. So let's go to the 4. So you have 1, right?
4, 1. It'll be
we have
0.
already marked it. Yeah.
At this, I'll take again absolute value of it and again put a negative. Then I'll go to 5. It'll be 1. Again, I'll do this
marked,
thing. 5, 6. 6. What is 1. The value? Minus 1. Again, this.
That is done. Yeah.
7. Again 0. 8. 8 is again 1.
Yeah.
I go to this. Now I'll start iterating over from the very first elements only. I check at 0, it is negative. 1, it is negative. 2, it is negative. 3, it is negative. At 4, it is something, but not negative. It is positive, right? It is positive. That means there hasn't come any number out of which, like after doing minus 1, a 4 came. Basically, that means our first number is 5.
Yeah, 4 plus 1. Okay, yeah, that's right. Yeah, that actually is a good approach. But the only issue what we were discussing, can we restore it back, this whole array? And that is what Leon was coming with a different way of doing it. But yeah, I think this is the good approach. And that is the most optimized way of doing it, right?
Yeah. Basically, all the relevant numbers, they are still here. All the non-relevant part of it, like that of negative, 0, and numbers which are greater than the size of array. So as size of our array, it'll be not of any use. So that's why we have just cutted them, all of them, and all the numbers which were of our relevant use, they are still here. Like it is still 8, it is still 4, it is still 3, and it will be still 2.
Yeah. So whatever is useful for us is still there. So you can restore those values you are saying, but you cannot restore the ones which you have already destroyed, which are out of bounds, right? But we never know what is the input array going to be and how they are going to use it. So it would be like, if we just destroy a single value, whether it will be okay or not, we are not sure. So, but I think this is the only best approach we can do, given the constraints here, right?
Yeah, right.
Yeah. Okay. So that's good. I think we had discussed all the approaches. So, so anyone wants to share anything? Uday, you have something, right?
So if we don't mind the order, I mean, there's one more approach by swapping. I mean,
Okay.
it won't change the values, but the order will be changing.
Mm-hmm.
Order array element order, right?
Huh?
I mean, order in the sense you are telling the elements inside the array would be changed.
Yeah, the element
Indexing of
values
those
won't be
elements.
changing, but order will be changing.
How will that work?
It's based
Can we
upon the
take an
similar.
example, quick example? We don't want to waste time now more, but yeah. Can we take an example?
Yeah, so basically if the value is I, we
Will you
swap
share
it
the
with
screen?
okay, sure.
Let's be quick because it's almost 10:23 now. Okay.
Yeah.
No, let's do it on a whiteboard because I think this will be very difficult to understand.
Okay. Can you someone tell the values?
Okay, which one you want? The second example, third example?
Yeah, anyone should.
Okay, 3, 4, minus 1, 1.
Yeah, so the first value is 3, right? So the 3 should have been at, I mean, I'm trying to aim the array as AI should be I plus 1. I will try to write it.
Okay.
Element 3 should be at third index, right? That is what you want to see.
Yeah, 2.
Only because of 0 indexing. Okay, yeah.
Yeah. Yeah, so I'm trying to achieve this equation. So, so I am trying to make the array indexes like this. So AI is equal to I plus 1. If I so if I find an index that is not having this I mean, not satisfying this condition, that would be the index that is not occurring in the value. So here A of 0 is 3. So I try to keep the 3 with, I mean, at 2.
Okay.
So I will swap minus 1 with.
Okay.
Yeah. Now I mean, since this is minus 1, I will go, I will, I mean, this won't be used. I mean, I will ignore the negative ones. And this is 4. If it is less than, since this is less than the yeah, length, I would use this one as well. This is also 3, and this value is equal to I plus 1. So I would retain the same. And 1, I would try to keep it at the 0. I would
So
try
you
to
swap that. Okay.
Yeah. So this will become minus 1. And
so it's trying to put the element at its correct indices, right?
Yeah.
Okay.
Respective indices, yeah.
Okay, you want me to put that? I'll put it. Okay, just leave it.
Yeah, we got it, I think. Yeah.
Okay.
Okay, I think, yeah.
After that, what would you do?
Okay, yeah.
Yeah,
we
so
did
I
that
will
one.
click, I mean, similarly, people are doing which is the index that is not positive they are checking, right? I will try to similarly check for this equation. If where is the index that is not having this I plus 1 value.
Okay.
Okay, so index 1 is 0, 1. Is 0 is 1, so that is okay.
Yeah, so here 4 is not equal to I plus 1. I mean, it should have been 2, but it is 4. So this would be the answer.
Answer. Okay, makes sense.
Yeah. That's a good one. I mean, less.
Yeah, we are just doing swapping here instead of actually going through and checking all the other values in there, right? Okay.
I mean, this concept you use many places, like detecting two duplicate numbers in an array. what he's doing, trying to put the elements at its correct indices, and he's checking if that particular element is at not correct index. That means that could be the potential answer for this.
Okay, so if you have two duplicates, we can use it. Okay.
Yeah. Only we need to take care of it should not. So that's, I mean, if it is repeating outside the range, too many, like in last example, all the elements I think is going out of the range, right?
Right.
So in
Third
that,
one.
what Uday, so what will you do?
In that case, actually, nothing is going to happen because it's just going to skip over.
Yeah, if it is less than index itself, I'm trying to place it. Otherwise, I will try to keep it the same.
Yeah.
Yeah. Question: why it have to be AI equal I plus 1? Could AI equal I
Based on the,
work?
You can make it work, but I mean, since we want that first positive integer, right? But here the indexing starts from 0. I mean, you can make it work, but you need to take care of other cases.
Generally, it's like that. The one they were sharing, like trying. I mean, add if it is a 0 indexing, add 1 plus to the ith value. I mean, whatever value, increase the value by 1. Yeah, we can do other way, but that would be like.
Yeah, but that's a good thing. Yeah. So we
Yeah,
discussed
exactly.
most of the solution and many solutions about the last one. That's good.
Yeah, sure.
Okay, so let's wrap it up. Can we
Nice.
stop the recording? Yeah.